You will hear a history lecture on a massive 19th century mapping project. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning. Today we turn our attention to one of the most audacious scientific endeavors of the 19th century, the Great Trigonometrical Survey. Launched in 1802 by an infantry officer named William Lambton, the initial objective of this colossal project is often misunderstood. Lambton's primary proposal wasn't actually to map the local territory, nor to measure the length of the equator. Rather, his scientific goal was to calculate the exact curvature of the Earth by meticulously measuring an arc of the meridian from the southern tip of the peninsula heading north. The early years of the expedition were agonizingly slow. You might assume that hostile local rulers or the torrential monsoons were the main impediments to their progress. While the weather certainly caused delays, the earliest diaries note that the most consistent daily threat to life wasn't meteorological or human, but rather the ferocious wild animals that populated the dense, untamed jungles they had to traverse. Compounding these environmental hazards was their equipment. The centerpiece of their operation was a custom-built great theodolite. Modern surveying devices weigh mere kilograms and can be carried in a backpack, but this brass behemoth was monstrous. It didn't just weigh a few hundred pounds. In fact, the entire assembly exceeded half a ton, requiring a specialized carriage and a team of men just to move it a few miles. Operating this massive instrument presented its own challenges. During the day, the sheer intensity of the sun created severe optical illusions, making distant reference points appear to shimmer and shift. To counteract this visual distortion, rather than working at dawn as initially planned, the crews were forced to conduct their precise observations under the cover of darkness, relying on distant signal fires, simply to avoid the blistering heat. When George Everest assumed command of the project decades later, he completely overhauled the methodology. Instead of relying on linear routes or scattered astronomical fixes, which were prone to cumulative errors, he implemented an unbroken, overlapping grid system composed entirely of triangles. This geometric framework allowed them to constantly mathematically verify their own measurements. Of course, the British engineers received the historical credit, but the absolute backbone of the enterprise was the local Indian laborers, known as Kalasis. Their duties went far beyond merely acting as porters for the heavy gear. In order to establish that crucial, unbroken line of sight between measurement stations, these men were constantly employed in the grueling manual task of hacking away the thick vegetation, essentially carving straight sight lines through ancient forests. Perhaps the most famous outcome of this grid system was the measurement of Peak 15, later renamed Mount Everest. Interestingly, the survey team never actually set foot on the mountain itself. Because the ruling authorities strictly prohibited any foreign presence across their borders, the surveyors were entirely denied access to the territory of Nepal. They had to calculate the mountain's record-breaking height mathematically from over 100 miles away. As the grid approached the Himalayan range, however, a baffling anomaly emerged. The sheer gravitational mass of the mountains was actually pulling the plumbobs sideways. This invisible gravitational deflection severely compromised the accuracy of their delicate instruments, forcing the mathematicians back in the capital to invent entirely new formulas to correct the distorted data. The human cost of this endeavor, which spanned nearly 70 years, was staggering. However, it wasn't starvation, exposure, or falling from great heights that decimated the ranks of the surveyors. The primary culprit, claiming more lives than any single factor, was the rampant disease, particularly malaria, contracted in the lowland swamps. When the survey was finally concluded, it had achieved something unprecedented. It didn't just produce a list of coordinates or a geological summary. It provided the rigorous, flawless mathematical framework required to finally produce the very first accurate map of the entire Indian subcontinent, an achievement that fundamentally altered the administration of the empire.